Hello, so in this video we'll be talking about degrees of freedom and how to apply the degrees of freedom analysis. Okay, so degrees of freedom is associated with the degrees of freedom analysis, and degrees of freedom is often abbreviated DOF, so we can write degrees of freedom analysis . Alright, and to define this, the degrees of freedom analysis is a tool that you use when you approach problems and okay, so there is another definition of the degrees of freedom. This is basically what the degrees of freedom analysis allows you to do, and the more common definition of degrees of freedom is that it is the number of unknowns minus the number of independent equations. So our unknowns are going to be the values we're trying to solve for. Usually these are variables like x and y, for instance. And independent equations are going to be, in the name as it says, either equations or relationships. So that's going to be the information given, such as x plus y equals, or it'll say this in words. Okay, so let's look at a really simple case here. So if we're told to solve for x and y given that x plus y equals 3, and we look at this problem in terms of degrees of freedom, we have two unknowns, x and y, so we have two unknowns, x and y, and the number of independent equations, that's just this right here, so we have 1, and it's x plus y equals 3. So right off the bat you can see that we're not going to be able to solve for the exact values of x and y, because with the information provided we just simply don't have enough information. And here, if we apply the definition of degrees of freedom, we have that our number of unknowns minus the number of independent equations is 2 minus 1, and we have 1 degree of freedom. Alright, so what exactly does that mean if you get 1? So that means that one piece of info is missing. So if we're told that we have 1 degree of freedom, that means that one more piece of information needs to be given, or one more equation or relationship needs to be given or specified so that we can solve this problem. Alright, so when applying the degree of freedom analysis, we want our degrees of freedom to equal 0. So that means that when we use the definition, degrees of freedom equals the number of unknowns minus the number of independent equations. That means that our number of independent equations must be equal to the number of unknowns. Alright, so let's continue our simple case of the degree of freedom analysis. So we want to solve for x and y, and this time we're given 2 equations. So right off the bat you may be thinking, yeah, this is great, we can solve this problem because we have 2 unknowns and 2 independent equations, but we don't. So with a little bit of rearrangement, we see that these two are identical, right? So we do not have 2 independent equations. We only have 1 independent equation. So our degrees of freedom here is still 1. So this right here is basically giving the same information but in a different way. and if they do that, then we're still not able to solve the problem in this case. Alright, so to understand what independent equations are, basically what these do is they provide new info, and there is no redundant info. So when you're looking at this, so if this is equation 1 and this is equation 2, when we're comparing these, this second equation does not provide any new information, so this equation is basically a rearrangement of the first, and it is redundant. So that is why we do not have two independent equations. Okay, so let's look at our continued simple case, and this time we still want to solve for x and y, and we're given two equations, and now this time we do in fact have two independent equations. So when you go about solving this, you know to add these equations. And you'll just get that y is equal to 2, plug that back in, and x is equal to 1, and you've solved your problem. So I know this is a really simple case, but let's look at this problem using our useful degree of freedom analysis. Alright, so the number of unknowns is 2, still x and y, and the number of independent equations in this case is 2. We're told that x plus y equals 3, and we're also told that y minus x equals 1. Alright, and why do we have two independent equations this time? So when you look at this first equation here and this second equation, you'll see that each one is unique, and going from the first to the second equation, we see that the second equation is different. It provides new information that this equation does not provide. And another way to check that is you basically can't rearrange this algebraically or multiply it by any factor to go from this equation to this equation. Alright, and I know this is really simple, but the degrees of freedom analysis is really useful when you're looking at complicated systems. So there were only two unknowns, but in the future you may be looking at systems that have anywhere from 2 to 20 unknowns, and instead of just diving into that problem, you may want to start with the degree of freedom analysis and just see that the equation is solvable in the first place. Alright, thank you for watching.